going to determine whether a number is an element of a set. An element or member of a set is an object that belongs to that set. When you see a symbol that looks sort of like a fork turned sideways, that means that it is an element of a set. If we draw a line through it, it means that it is not an element of a set. Let's do some examples and it'll make more sense. So here we have three sets. Set A contains the numbers 2, 4, 6, 8, 10, and 12. Set B contains the numbers 2, 4, 8, and 10. And set C contains the numbers 4, 10, and 12. So let's do example number 1. Here's a statement that says that 4 is an element of set A. So let's go to set A and see if 4 is a member or element of that set. And sure enough, it has a 4 in there, so it means that that statement is true, that 4 is an element of set A. Let's go to number 2. There's a statement that says that 6 is an element of set B. So let's go to set B and see if there's a 6 in it. There is no 6 in set B. So that means that the statement that 6 is an element of set B, that is a false statement. Let's go to number 3. This statement says that 10 is not an element of set C. Let's go to set C, and there you do see that 10 is an element or member of that set. So therefore, this statement that 10 is not an element of set C is a false statement. Next, we have a statement that says that 12 is not an element of set B. Let's go to set B. And if we look at the numbers, no, I don't see a 12. So that means that this statement that 12 is not an element of set B, that is a true statement. So there you have it. Checkpoint. It's time to check your understanding. So pause the video for a moment and I want you to answer these on your own as to whether the number given is an element of the set given or is not an element of the set given. Okay, so let's take a look at 10, our first number, and we want to know, is 10 an element of the set given? Now, the answer here is no, that it is not an element. Now, even though you see the ellipses here in front, that simply means that this pattern continues with numbers that are less than 2. Now, if the ellipses were in the back, then it would have been a true statement that it would be an element of it. In other words, if you had the ellipses in the backs, meaning that it continues on and on with numbers greater than 8, but that's not the case. This set stops at 8, and it includes all numbers there of even numbers that are less than 8, but as long as it's an even number. But 8 is the greatest number there is. 10 is not a part of that, so again, 10 is not an element of that. Next, we have negative 11. So would you say that it is an element of the second set that's given? Well, we see here we have our odd numbers, and they're negative. So odd negatives, we have the ellipses, which means it's going to continue on to negative infinity as long as it includes an odd number, which means that it will include 12 in that set. So we would say that negative 11, it is a member of that given set. Last one, negative 5. Would you say that negative 5 is a member of the given set here of whole numbers? And the answer is no. Negative 5 is not an element of that set. Okay, how'd you do on those? Okay, I'm sure you did well.